Hello everyone, let me introduce myself. I am Facundo Carballo and today I will explain you all about deadlocks. Since what is a deadlock, when it happens, and how we can prevent deadlock situations in our programs. In this video, we will see deadlocks in Golang, but all the concept that we will see here about Go routines, it's the same logic that in other languages like C, C++, Python, Java, and others, where in those languages we use threads. Well, in this case, in Golang, we are using Go routines instead. Well, before we start with the video, I want to tell you two things. All the code that you will see here on this video, you will have it on a GitHub repo. The link to that GitHub repo will be on the description of the video. I invite you that you have it close to you while you are seeing this video because it will help you to understand better all about deadlocks. And second, if you like this kind of videos, please hit the like button and subscribe to my channel. That will help me a lot. So now I will let you with the video. Other concurrency problem is deadlock. Deadlocks are generated when two or more routines are trying to access to the same critical zone using mutex as their synchronization mechanism, but using that mutex in a bad way, like you can see here on this diagram. Here we have the routine number 1 and the routine number 2. Both of them wants to access to this value variable. It's an example very similar to this, because we have two routines that wants to get access to some resource, to some variable. And well, here we have these two routines that wants to get access to this resource, this value, but like we want to prevent race conditions, this other concurrency issue, well, here we apply mutex, a synchronization mechanism to prevent those race conditions when these two routines trying to get access to this particular resource. So to prevent that, we use mutex, but here we are applying mutex in a bad way, because this routine number 1 lock the mutex A first and then lock the mutex B, while this other routine first lock the mutex B and then lock the mutex A. When we have this situation where two or more routines are trying to get access to the same resource but with different order in their mutex, here we have a very clear situation of a deadlock. Because imagine this situation like you can see here on the timeline. The routine number 1 executes first. So this routine, the first thing that will do is lock the mutex A. Then, for any reason, the operating system quick that routine and put the routine number 2 to execute. The first thing that this routine number 2 will do is lock the mutex B. And can lock the mutex B because there is no other routine locking the mutex B. So, can lock the mutex B. The operating system quick the routine number 2 and put again the routine number 1 to execute. So the routine number 1 gets here, so left to lock the mutex B. And when the routine number 1 will try to lock the mutex B, the operating system will tell to the routine 1, wait, because the routine number 2 already have locked the mutex B. So you have to wait until the routine number 2 ends. Okay, the routine number 1 gets here blocked until the routine number 2 finish. But what happened? Here the operating system quick the routine number 1 because it's blocked and put the routine number 2 to execute. And well, when the routine number 2 start to execute, the routine number 2 will start here because the routine number 2 already locked the mutex B. So the only thing that have to do now is lock the mutex A. And when this routine try to lock the mutex A, the operating system will tell to us, as a routine number 2, hey, you have to wait here because the mutex A is already blocked by the routine number 1. So you have to wait until the routine number 1 ends. Okay, but the routine number 1 also it's waiting. And why this routine is waiting? This routine is waiting because this routine needs something that have the routine number 2, and the routine number 2 is waiting too because the routine number 1 have something that this routine needs. So here it's a clear, simple situation of deadlock where two routines are provoke a simple deadlock. And that's it only because we use in a bad order the mutex. If we use the mutex A first here, if that was the case, the coroutine number 1 can execute completely, and then the coroutine number 2 will execute completely again. But like we use this particular order of locking this mutex, we are producing a deadlock. So now we will see this example on code. So here we have 3 functions: a coroutine A, a coroutine B, and a deadlock function. This deadlock function, what it does is generate 2 coroutines, a coroutine A and a coroutine B, and then wait until these 2 coroutines ends. But what's happened? If we are provoking a deadlock, these 2 coroutines will never end. So what this coroutine A and this coroutine B does? Well, it's the same that we see here on the diagram. The coroutine A will lock the mutex A first and then lock the mutex B, and the coroutine B will lock the mutex B first and then lock the mutex A. At some point, when these 2 coroutines execute this first line and try to execute this second line, will generate a deadlock. So when our program gets inside of a deadlock, it will exit immediately, so our program will finish. Because if our program will not finish, our program will be waiting forever. So now I will show you this to see what happens when we have a deadlock. So I will execute this deadlock function to see what happens. And well, here we have the deadlock. It's like an error, but our code, if we don't know what is happened, we see our code and we think it's okay. But the only thing that we have to change here to prevent this deadlock is change the order of the mutex A and the mutex B in one of these 2 functions, because we have to do the mutex lock in the same order always. So I will lock the mutex A first and the mutex B then. So here I have to make that. And for the unlock, I recommend that always follow the same order. So here we have to unlock first the mutex A and then the mutex B. When we use mutex, we have to be sure that we use it in the correct order always. Because if we don't follow the order in some cases, we can provoke a deadlock, and we don't want that. So if I fix only the mutex order and try to execute again, you will see that will execute correctly. So here we can see that the function ends correctly with a resource A value of 2 and also with a resource B value of 2. And that's because, well, our coroutines, each one increment the resource A by 1 and then increment the resource A by 1 and the resource B. So this resource value was incremented twice by 1. So when the function ends, we expect that these 2 resource values gets on 2. So it's fine. And well, that's all for this video. I hope that you will understand all about deadlocks. And well, if you like this kind of videos, I will ask you again that hit the like button and subscribe to my channel, because that will help me a lot to grow up on YouTube. And well, see you on the next video.